Welcome to the University of South Florida Department of Anthropology webinar series titled Race and Power, Deconstructing an Illusion. This is an ongoing series that provides an anthropological perspective on the concept of race and its intersection with power. Before we begin, we want to make a formal land acknowledgement statement. The Department of Anthropology acknowledges that the University of South Florida resides on the traditional homelands and territories of the Seminole, as well as other historical groups, including the Calusa, Tocobaga, and Tocobaga. Today, the state of Florida is home to the Seminole, Miccosukee, Muskogee, and Choctaw, and to individuals of many other Native groups. As a department, we recognize the historical and continuing impacts of colonization on Indigenous communities, their resilience in the face of colonial and state-sponsored violence, and we fully support Indigenous sovereignty. We will continue to work to be more accountable to the needs of American Indian and Indigenous peoples. We would also like to make a formal statement on anti-Black racism. We acknowledge that anthropology as a discipline is rooted in racism in the guise of colonial projects. And despite efforts to end scientific racism and include a diversity of voices, racism persists in the academy. We affirm our commitment to continuing to overcome long-standing structural barriers to access in higher education, the discipline of anthropology, and academia in general. We invite you to take a look at the Diversity and Inclusion tab on our department website for information on a variety of initiatives that our department is engaged in. With that, I would like to introduce Dr. Lorena Madrigal, who will be presenting tonight with her talk on what's new in human variation. Dr. Madrigal is a full professor in the Department of Anthropology here at USF, a past president of the American Association of Physical Anthropology. She is a Biological Anthropology Executive Board member of the American Anthropological Association and a fellow of the American Association for the Advancement of Science. So we are very happy and privileged to have Dr. Madrigal with us here today. Before I hand the floor over to her, I would like to call your attention to the Q&A button and we invite and even encourage you to ask questions throughout this presentation, as there will be time for a Q&A at the end where Dr. Madrigal will address those questions. So with that, I will hand the floor over. Thank you.
I thank you very much for this opportunity. And today I will be discussing the recently published master's thesis of my graduate student, Lucio Regis, and which was published just last month in the American Journal Human Biology. My colleagues in this team were David Guthrie, who graduated a few years ago from our program, Professor Ming from the chemistry department, Caroline McLean, who is graduating this semester. Francisco Gonzalez is an undergraduate from USF who never even took a class from me and who is getting a PhD in Colombia in mathematics. And that's me. I also want to thank my wonderful Department of Anthropology at USF, the organizers, and the administration under our fearless leader, Dr. Jackson. I'm very proud of my Department of Anthropology and for everything that it stands. So today's talk is going to be very briefly. We need to talk about the consensus about the origin of Homo sapiens. We need to talk also about how, when we dispersed out of Africa, the dispersal affected how the level of human genetic diversity. And then we will talk about how this unique pattern of genetic diversity compares with other species and how it affected our unique pattern of human genetic diversity. We will then look at the data and compare the data with folk views of genetic variation. And then we will turn to our new paper just published, this one. So let's begin by talking about the most fundamental question in biology. What is a species? And I would like to illustrate this with something that we're having to deal with in Temple Terrace, where USF which is neighboring USF. What is a species? Well, I don't know how many of you have had a problem with coyotes if you live in Temple Terrace, but we're having an issue with coyotes. And you are not supposed to leave trash out, and you need to be careful if you have a cat or a dog, because they're you know you have to be careful with your cat because they can eat your cat. But if you have a dog, then you have to be careful because that dog may end up being pregnant. And so this is an issue that sometimes I have problems with my young undergrads, that they come to college thinking that species barriers are very clear, and that is not always the case. So this is relevant when we talk about the origin of Homo sapiens. I'm just saying that for the moment, just to keep it in mind. So that's like the background, the theoretical background. The other issue, let's talk about the methods. The fossil record is getting better. The ancient DNA is getting wonderfully better, because only a few years ago, the only thing we could get was mitochondrial DNA, but now we have nuclear DNA. Sadly, the Y chromosome is still missing because it's tiny, tiny little. So we don't have mitochondrial DNA. I'm sorry, Y chromosome. We don't have the Y chromosome. And what is wonderful is that we are also getting much better at getting the collection with living people, and the two methods are confirming each other. The archaeology is fundamental, and that is also getting better. So in general, it's just a wonderful time to study human evolution. So let's go back to the question of the speciation of modern Homo sapiens. The consensus is that it occurred about 300,000 years ago in Africa, but the consensus is also that there were several hominin lines in Africa. Now, let's talk about what it means to have these different hominin lines in Africa living at the same time. The consensus is that there were these different species lines. They respected their species lines, just like coyotes respect your modern dogs. But sometimes people get confused and they cross barrier lines, and a few hybrids result. So in the same manner, around 300,000 years ago, there were multiple hominin lines out of Africa, and they perhaps were more morphologically defined. And they also respected each other's hominin lines. But it doesn't mean that there were not hybridization. In fact, there is a cave in Siberia, which was a hot place for singles of all types. So going back to that 300,000 date, this is a very famous specimen, and it comes from the Broken Hill Cave, which likely is the type specimen from which our species originated. And there's a 2021 paper that redates it to about, look at that, 299 plus or minus 25,000 years. Now, but before that time, it is important to remember that there were several migrations, including before 2 million years ago, of some hominins out of Africa with non-modern hominin plants. So, and we have evidence that these little hominins walked with their little tiny legs all the way to the Philippines and Indonesia. So if you don't remember what I mean by Australopithecus or non-modern body plants, here it is. So this is a Homo erectus who looks pretty much similar to you and me in terms of the body plan, with long legs and longer legs than arms. In contrast, this is a Homo habilis or an Australopithecus-like thing, and we have evidence of these little hominins with tiny little legs and long arms, of them all the way in Philippines and in Indonesia. And I always think of these little hominins walking on those little short legs with their little hominins walking out of Africa. And how did they get all the way out in Flores Island and Philippines? So all of these migrations were already taking variants out of Africa. So, in sum, the consensus is an origin in Africa with likely interbreeding with other populations within Africa. But because the speciation is as recent as 300,000 years ago, the genetic clock of our species was started. And we have very, very little genetic diversity. So the clock was restarted in Africa, which explains why some African populations have an enormous amount of genetic diversity. But there's always the question of whether there was also some gene flow with other hominin populations within Africa. And the term that is used is introgression. Now, after Homo sapiens left Africa in small groups, they lost genetic diversity by genetic drift. But what is interesting is that they also gained genetic diversity from other hominin groups that were already out there. Particularly interesting is Neanderthals and Denisovans. But there's also the question of whether the little tiny little hominins also contributed. That is an interesting question. So let's talk about how is human genetic diversity distributed. In comparison with chimpanzees and gorillas, who are our closest relatives, we have very, very little genetic diversity. And it is very clear that our genetic clock was restarted about 300,000 years ago. So let's talk about what it means to have very little genetic diversity as a species, because in my opinion, in textbooks, this has not been well explained. This is what genetic diversity looks like in chimpanzees. I can pick up a genome of a chimpanzee and I can tell you from what area of Africa it came from. From what area of Africa it came. This is what human diversity looks like. So this means that most human genetic diversity is shared. Then there's a little bit of human genetic diversity that is not shared. For example, not all human populations have alleles that allow you to survive in areas of high malarial endemicity. Or not everybody has alleles that allows them to be adapted in an area of low oxygen content, and so on and so forth. Not everybody has cystic fibrosis alleles. So what I'm saying here is that chimpanzees do have distinct morphological and genetic groups. Not humans. Humans share most of their genetic diversity. But how much, to be exact? it's the great majority of their genetic makeup. And actually, there are some human populations that have most of the genetic diversity, most of the genetic variation of our species. It all started with the work of the great genetic population, the great genetic population population geneticist Richard Lewontin, who did something which I don't think has been well explained. In 1972, he took gene frequencies of 17 loci whose allele frequency was recorded in, let's say, the little village in the middle of nowhere in the Amazons, and then in populations in Brazil, in New York, in Madrid, in London, in Beijing, and then he did the following. So here you have two populations of the same species. Population 1, so let's look at these species. In case 1, the two populations of this species are 100% homogeneous, and they share 0% of the variation of this gene. In case 2, the two populations of the species are 100% identical, so they have 0 variation between them. Then, in this case, 100% of the variation in the species is within them. In case 3, both populations share allele B and allele A, but at different frequencies. So this is exactly what Richard Lewontin did. He collected the allele frequencies in these two different places, and then at the continental level as well. So he figured out that in population 1, B is found at 4 divided by 12, and that in population 2, B is found at 8 divided by 12. That is not a very difficult divisions to do. And so these are the allele frequencies. So this is exactly what he did. And this is what we do in the field of population genetics. So he did this at the village level, at the continental level, etc., etc. So this is what I mean when I say that I don't think this has been very well explained when people say more variation within than among groups, because I don't think many people have taken analysis of variance. This is what this is. This is an analysis of variance. So I prefer to explain this in terms of sharing of genetic variance. So what I tell my students, what I'm trying to explain this is as follows. If most humans were to die due to a terrible catastrophe and only 100 people survived, what proportion of all human genetic diversity would be saved in those 100 people? Between 85% and 94%, depending on the population. And in addition, now we know that not only do we know that most human variation is found in Africa, but we also know that as populations moved away from Africa, they lost their genetic diversity through genetic drift. I would like to remind you that genetic drift is most prevalent in small populations. And most of these populations that left Africa, from the little tiny hominins to later hunters and gatherers, most human populations are small until we had the adoption of agriculture. So most populations that left Africa were small. And so what we see is that as human populations left Africa, they lost genetic diversity. Now, a 2020 paper confirms that it's not just African populations that have most genetic diversity. It is the Kun people who have the greatest amount of genetic diversity. So this is taken from this paper published in the Molecular Biology and Evolution, published in 2020. And basically, this is the best way in which we can represent genetic diversity in our species. There is the Kun people here, then there's other Africans, and then there's non-Africans. And so that encompasses all human genetic diversity in our species. When we look at geographic distance and human variation, we do not see clusters of green people, yellow people, purple people, blue people, etc. No. When we look at genetic diversity, we look at a map of geographic distance. So we see populations from Africa, we see North Africa, we see Europe, we see Near East, we see Tibet, Korea. From Asia, we see, of course, the American native populations. So we see very clear clusters, but not a cluster. We see Asia and American populations, and then the Pacific populations. There are no separate clusters of people. So now we get to folk taxonomy, because this is what science says, without a doubt. This is what science says about the distribution of human genetic diversity. And one thing that I failed to mention when I was discussing the work of Richard Lewontin is that the proportion of human genetic diversity that is shared had been repeatedly being found to be 84, 85, 80, 79, 84, etc., until it would jump to be 94% in the very famous paper by Rosenberg et al. 2002, when they did it not with proteins, but looking at DNA. So that's why it is now up to 94%. 94% of all human genetic diversity is shared when you're not looking at the protein, but at the DNA level. So this is what science says. Now, this is what some taxonomies say about the distribution of human diversity. Some humans have A here, some humans have B here, some humans have C here, some humans have nothing here. I don't know. People are green or yellow, or people are short or tall, or people are A, B, C, or D. So the question arises, since we are anthropologists, we like to look at different cultures, right? Which folk taxonomy is right? Which one should we choose? And I actually wanted to share with you a really interesting situation that happened to me in the year 2016, because in 2016, I went through 3 miraculous racial transformations, and they were: I started my year in the US, where I am a Hispanic. Then in the summer, I went back to my beloved home country, Costa Rica, and in Costa Rica, I am a Costa Rican. Then I came back to the USA, where I again became a Hispanic. In December, I went to India to do wonderful field, and in India, I am white. Then I came back to the US and I became a Hispanic. So my question to the audience is, which one of these folk taxonomies is right? Because that's what they are. They are folk taxonomies. So I would ask the audience to think. I would like to ask the audience if they have been in such a situation in which they have been racialized by different cultures differently. Because people who have grown up in different countries or have had an extended visit in other countries have had that experience, and maybe we can talk about it later. It's very fascinating. My experience in India, in particular, was very interesting because the place where I was extremely rural, and they had a very hard time understanding that I could be white, yet my first language was not English. All right, we can talk about it later. So given that there is all of these folk taxonomies about human diversity, then I would submit that we look at what scientists have to say about taxonomy of humans. So what do they have to say about the taxonomy of, what do have scientists have to say about human races? How many are there? And grandfather Linnaeus was the first one to propose that there were 6 races. Buffon proposed 6 races, but no, they were not the same 6. Blumenbach, who was a student of Buffon, proposed 6. Blumenbach was all for being more concise. Cuvier, 3. Now, between 1828 and 1900s, Deniker had studied a lot more people, and so he said, no, it's 29. Weinert said, no, you are going too far, it's 17. Not 20, but 17. And so, as you can see, anthropologists, biologists have failed miserably at finding the number of races because there are no human races, because humans share most genetic diversity. I use a really nice reading chapter in my human variation classes, and this author says that the problem is not with the data, the problem is with the framework of mind that anthropologists have had until recently, looking for a number of races that don't exist. So the question arises, is the concept of race a vampire? Because it won't die. So now I would like to talk about one of the papers that has been quoted, that has gotten one of the highest quotations in the American Journal of Physical Anthropology by Clarence C. Gravely, published in the year 2009. It's called How Race Becomes Biology, Embodiment of Social Inequality. And I know that many of us have assigned this paper in many of our classes. Gravely argues that as long as there is social inequality, race exists. As he says, race becomes biology. He cites examples such as after 9/11, women who had Arab sounding last names had an increase in miscarriages, for example. Since day one, many of us have not agreed with Gravely's position. This piece here presents one of these positions. Hockman says, my concern is not that the claim that racism can shape the biology of racialized groups, but rather that this phenomenon can be described as an example of how race becomes biology. Race can only become biology or anything if race is real. While Grafley's discussion of racialized groups is not metaphysically invested in the reality of race, his talk of race becoming biology assumes that race is real. That is not my position necessarily. My position, I have always had a problem, and actually, I participated in a seminar with Grafley, and we actually had an encounter on this point, because so my problem with Grafley's position is that race has its origins as a biological term, just like species. And when patients and doctors talk about race, they are talking about biology, without understanding that they're talking about racialized groups with hundreds of years of unequal access to resources, of brutalization, of colonization and imperialism. And moreover, not that many doctors have had population genetics of humans. Therefore, we anthropologists might be using the word race to mean racialized groups. We are using the word race to mean racialized groups that have been marginalized. But I'm asking you, can we be sure that doctors, medical examiners, and sergeant major police officers mean the same? Can we be so sure? How many doctors have had population genetics in their background as undergraduates? I know who has had that background are undergraduates. There it is. Not that many doctors have had population genetics. And I wanted to share with you the following intake form from a clinic. Ethnicity or race. So here they're comparing African Americans, which is an admixed group from the US, with Caucasians, which is a racialized view and a racist view from I actually meant to say from the 1800s. A Caucasoid view comes from the 1800s when there were races. So this means a race. This means nothing but a race from the point of view of the 1800s. How is this? And then Asian, this is an entire continent. How is this comparable with a clearly admixed group found in the US, where American is implied, not the continent, but one country? How are these comparable? And I'm not going to discuss Hispanic. So my question is, if we use the word race and we continue to use it, are we sure that doctors are using it in the same way that we are using it? So why do biological anthropologists study human variation? Because if you think about it, basically humans are the same. Humans don't vary. So what is it that we want to study human variation for? Because we are, by looking at the consequences of racism, by looking at the transmission of ill health across generation, is one of the best ways of understanding human diversity. Because for many of us, health is political. And moreover, we can actually quantify this statement. So what is really interesting is that not only have we quantified the lack of diversity in humans and we have repudiated the validity of any concept of biological race, we still wish to understand why humans vary. And what is really cool is to focus on this 5 to 15% of genetic diversity by which humans vary. We ask questions such as, so did Tibetans actually get the gene that allows them to live in such high altitude? Did they get it from Denisovans? It looks like yes, it looks like yes. So they have this fantastic ability to live in high altitude and be adapted to hypoxia, which means low oxygen. It looks like they got it from Denisovans. Now, don't tell me that's not cool, because it is super cool. Did humans adapt repeatedly to malaria? Apparently, yes, and they're not all from Africa. So it is within this context that my team and I, and so Lucy Regis just graduated, yes, that we're asking a question: why would multiple populations evolve high frequencies of an allele that for all intents and purposes is deleterious? So we're framing our studies on human genetic variation in this context, where we look at that little bit of genetic diversity which is not shared. So since the 1990s, this mutation, so this is a mutation, this is a SNP, or a single nucleotide polymorphism, where there's a single change in this position from a C to a T in the MTHFR gene. And it started being documented in European and East Asian populations, which, as you notice, is not the populations that we ended up studying. But this is where it was first studied. So this substitution, the wild type is C, the substitution is a T. This is a codominant system, meaning that the heterozygote isn't expressed. And they are both associated with numerous deleterious cardiovascular and fertility problems. Now, this gene is associated with the folate metabolism. So I'm going to ask you to remember what you learned about skin color and metabolism. You may remember that the main idea, the main hypothesis about why we humans have dark skin is protection from folate depletion. So folate depletion is associated with neural tube defects. I hope you remember that. So because this gene interacts with the folate metabolism, and these two genotypes are associated with the folate metabolism, women and men who have these two genotypes tend to have problems with fertility, but mostly neural tube defects. So I'm just going to leave it like that. Lucio knows a lot better about the biochem of this. So Richard Lewontin says, if it quacks like an adaptation, it probably is an adaptation. Thank you so much, Richard Lewontin. I know that many of you are thinking, well, you know, if it is found, does it sound like sickle cell anemia? I mean, because this is, you know, sickle cell anemia is not beneficial, but it has on its own, but it has benefits, right? Well, we have reviewed all of the proposals on the benefits that it has, and frankly, none of them have been substantiated to an extent that we left the paper open, and we didn't propose any hypothesis. So then Richard Lewontin says, well, if it does not quack like an adaptation, then probably it's not an adaptation. Well, then we have a massive problem with the many classical studies done, many of the clinical studies done before our population genetic study. And this is the problems that we have. And that is that they left out the populations with the highest allele frequencies in the world. Our study took place, well, and let me tell you why. Because all of the clinical papers have been done in Asian and European populations, which have an allele frequency of about 0.3, 0.4. But there are many indigenous populations in Mexico and Central America whose allele frequency is astonishingly high. And I mean astonishingly high. So there are some indigenous groups in which the T allele is higher than the normal allele. And there are more TT individuals than there are normal individuals. So there are no other populations in the world like that, like this, like in Mexico or Central America. So there's actually a population in Mexico that has a frequency of this allele of 0.9. So I want you to think about it. I mean, you know, as an anthropologist, that for sickle cell anemia, the allele of sickle cell cannot go too high because then you will start producing too many sickle cell anemic individuals, and that would not be good for the population. So how are these populations making it if there's so many things that go wrong with these individuals? But you see, the problem is that these populations have not been researched. So this is the work of my former student, David Godfrey, and we definitely see a decline. You see that the decline is obviously related to sunlight, which makes sense because we're talking about folate and skin color, and then also is related to high altitude. The populations with the lowest frequency of the allele are directly exposed to the sun. The highest frequency of this allele is found in populations that are sheltered from the sun. So, for example, Q is the frequency of the T allele, is found at the highest frequencies in, for example, in Mayan populations that have sheltered from the sun. This is the Triquis. These are the Triquis who have the highest frequency in the world, 0.9. And then, in contrast, you see these are the populations that are more exposed to the sun. So they have direct exposure. This population here is high altitude. So they have more exposure. And what I find incredible is that even within my little home country of Costa Rica, you see decline. So these populations in the north are more exposed to the sun, whereas these ones in the south are less exposed to the sun, and they have very high frequencies. So there's no question that there's a decline and that it is related to the sun. And so we're talking about genetic diversity and the type of genetic diversity that these communities have within, you know, it's tremendous. Basically, 40% of individuals here are heterozygote, and 41% of the variance is found between individuals within these communities, these little communities. Only 20% of the variance is found among these populations. So this pattern of variation is highly unusual. So we see an overabundance of heterozygotes. And what is even more bizarre is that when we tested the Hardy-Weinberg equilibrium, which our undergrads love to do, all but one of these populations were already in equilibrium. The one population that was not in equilibrium was due to the fact that it lacked enough heterozygotes. So it looked like natural selection has brought these populations to this unusual type of frequencies and it just left them there. How are they alive? That's what I want to know. How is it possible that there are all of these communities with more TT homozygotes? How are they alive? So we were talking about, I said before that biological anthropologists are interested in human variation because for us, health is political. So I'm just going to say this very softly. These results have so much to do with colonialism and unequal access to resources. All of these clinical studies have been done on Euro and Asian ethnic groups, all of them. We used published data, but we are really the first group that is raising alarm about the fact that these populations must have evolved these alleles for an evolutionary adaptive reason, and therefore they must keep their lands, way of life, etc. Our fear is that if they move out of there and start eating potato chips and Coca-Cola, they're going to start experiencing all of the clinical issues that Euro and Asian ethnic groups are facing now. We are not ready to suggest a likely selective mechanism at all at this point. Our hope is to embark in a collaborative field work, and that would be my student, Caroline, that she would be doing field work with at least one of the native communities in Costa Rica in collaboration with them and with members of the anthropology department at the University of Costa Rica, and also perhaps with the Ministry of Health. And we are already starting discussing this with them. Our hope is to collaborate with them, with the women, and start to collect reproductive histories of these women of different phenotypes and understand how they survive. Is it their diet, etc.? Now, there's other public implications because the second population with the highest frequency of this allele is Mediterranean populations, such as Spanish, Portuguese, and Italian ones. So that means that people like me, my two parental populations are Central America or Mexican indigenous populations, and then the Spanish one. So we, the living people, the people who live, people like me, are a double jeopardy. So whereas it is true that the entire world is undergoing an epidemiological transition, not all populations have such high frequencies of this allele. And so we must not only preserve the native people's culture, food, and ecology, but also learn from them and see how they live with this allele. I'm going to read from this sign. It says, autonomy now. The indigenous movement walks forward, looking backwards, because our future is not what is coming, but what it was. This skeleton has the names of all of the groups, indigenous groups in Costa Rica. Here you see pictures of Father Maize, and this is called a pilon, where you mashed it, and this is a famous rock, a famous stone sculpture. We dedicate this work to the memory of our ancestors, including those who were gunned down in our ancestral lands of El Paso and Costa Rica. Lucio, Lorena, and the team. And now it's time for questions and comments.
Thank you very much, Dr. Madrigal. We're very happy to hear your presentation, and I appreciate the vulnerability you share at the end with personalizing the experience. We do have a question here asking about whether or not taxonomy can be thought of as racialized.
Taxonomy of, is that the question? I mean,
yes, it asks, could you say taxonomy is under the category of being quote unquote racialized?
Well, I know that I use that the word taxonomy to talk about racial classifications, because that's what they are. So now when we talk about taxonomy of other species, then there is no, then we're not talking about races anymore. So so maybe I should not have used that term, but it is a way of taxonomizing. I mean, a taxonomy is a way of classifying. So I'm frankly don't understand the question. Maybe the person can rewrite it.
Okay, I'll see if that comes in again. Do we have any other questions today for Dr. Madrigal? And just so you know, Dr. Madrigal, a few people did have to go ahead and leave and have indicated that they would like to speak with you in more detail at a later time.
Oh, I would love to, yes.
Do we have any more questions from people in the audience? Okay. Well, we thank you again, Dr. Madrigal, for sharing your research, your wealth of knowledge, and your personal experience with us today. And if we can just get the thank you slide up, I'd like to thank everyone for coming today. Let you know that there will be an evaluation of this event coming up in the in an email, and that we will be having another webinar that I encourage you to attend on March 22nd, looking at the misuse of race in forensic anthropology. And so please see our YouTube channel where this event will be recorded and posted publicly so that you can use it in classes of your own that you're teaching, and so that you can refer to it for your own purposes in the future. We hope to see you again soon.